Okay, let's just dive right into this explainer and tackle a pretty hard truth. Building an AI agent, it's incredibly fun, but proving it actually works in production, well, that is the real challenge. Look, here's something nobody really tells you when you start wiring up these AI systems. Giving an agent some tools and watching it execute a task perfectly on your very first try, it literally feels like magic. You sit back and say, yes, it works. But does it? Just because it worked that one time you tested it, absolutely doesn't mean it's going to survive the sheer chaos of real-world production. That nagging gap between a successful test and a reliable bulletproof product, that is bridged by a rigorous process called evaluation, or evals. And honestly, if you ever want to launch a truly enterprise-grade agent, mastering your evaluator workflow is completely non-negotiable. So here is our roadmap for the explainer today. We're going to move systematically through the production gap, the paradigm shift, decoding those agent metrics, building your golden data set, the 4 graders, and finally, we'll tie it all together with a continuous loop. All right, let's kick things off with section 1, the production gap, vibes versus reality. We really need to look closely at the difference between a demo that works magically once and a robust system. Think about it. When an AI agent breaks in production, you have to know exactly where and why it failed. An agent isn't just generating one simple text answer anymore. It's executing a whole sequence of decisions. It picks a tool, calls it, reads the result, and then decides what to do next. There are literally dozens of places where things can quietly go sideways. If you rely on vibe evals, basically just eyeballing a couple of outputs and saying, yeah, looks fine to me, you are going to be in serious trouble. In fact, research shows there is a massive 1/3 performance drop between how models score in a controlled lab environment and how they actually perform when deployed to real users. Now, you might be thinking, wait, don't we have leaderboards for this? Well, yes, we have benchmarks. But benchmarks test the underlying model on generic public tests. A model could be sitting right at the very top of every leaderboard and still completely fall apart for your specific use case. Why? Because that benchmark never saw your unique data, it didn't use your specific prompts, and it definitely didn't interact with your actual users. You need custom AI evals to test your specific system on your own data. To put it simply, benchmarks are how you pick a starting model, but evals are how you prove your agent actually works. Moving right along to section 2, the paradigm shift. We're looking at traditional ML versus LLM agents.
So why is AI agent evaluation so much harder than what we used to do in traditional machine learning? Well, the entire game has changed. In traditional ML, your output was incredibly clean. It was a simple category like spam or not spam. And because it was so clean, you could easily compare it to an answer key and calculate perfectly objective metrics like accuracy or an F1 score. We were basically just grading a multiple choice test. But today, with large language models and agents, the output is subjective, open-ended text, or complex action sequences. There might be 100 good summaries of an article, and 2 truly great ones can look entirely different from each other. We've shifted from grading a simple multiple-choice test to grading a complex, subjective essay where multiple right answers exist. And as we all know, grading an essay requires a rubric.
Which brings us perfectly to section 3, decoding agent metrics. Let's make some sense of all this alphabet soup. To grade these new AI essays effectively, we need to cut through the noise. You're going to reach for these 4 core metrics over and over again, depending on your task. First, you have relevance, which simply asks, did the output actually address what the user prompted? Then you have faithfulness, sometimes called groundedness, which is basically your hallucination check. Is this answer actually backed by the real source data? Correctness checks if it matches the expected factual answer. And finally, coherence measures if it actually reads well and flows naturally. If you're building a RAG system, retrieval augmented generation, you'll lean heavily on faithfulness to catch bad generation and relevance to catch bad retrieval. We can actually organize all those overwhelming metrics into 3 distinct, digestible buckets. First up, classic overlap metrics. These are your old-school, fast, cheap checks like blue or rouge that look for exact word matches. They're great, but they are totally blind to meaning. 2 sentences saying the exact same thing in slightly different words will get a terrible score here. That is exactly why we have the semantic bucket. This uses embeddings to compare actual meaning, making it way better at handling paraphrasing. And finally, the model-based bucket. This is where you literally use an LLM as a judge to do the grading for you. This is really the only bucket flexible enough to handle the messy, open-ended, creative outputs that real AI agents produce. Let's look at this from a pro perspective. Building tools like a multi-agent terminal generator proves that programmatic evaluation is the absolute secret to scaling your development.
As a practical example from our sources, imagine building a robust demo package every week. Code, a README, slide decks, social posts. That takes a massive amount of time, right? But by leveraging a terminal native coding agent like Mistral Vibe, you can define custom sub-agents with specific tools. One does research, one writes code, one drafts slides, and crucially, one runs programmatic evals right in the terminal to confirm the code actually works before finalizing everything. What used to take a whole afternoon now literally takes seconds. It's a complete game changer for the developer workflow.
All right, next up, Section 4, the golden data set. This is the single most important habit you can build. Before you even think about touching those metrics we just talked about, you need to establish the absolute rock-solid foundation of your eval process. If you take one habit away from this explainer, let it be this. Do not start by grabbing a bunch of metrics off a list. Start by building your golden data set. Think of a golden data set as your own custom answer key. You deliberately fill it with your most common use cases, your super annoying edge cases, and your known failures. And the best part? It doesn't need to be huge. Just a highly curated collection of 5 to 20 specific inputs paired with exactly what a phenomenal output looks like and what a complete disaster looks like. Here's the secret the pros know. You build your golden data set first, and you let the metrics naturally fall out of it. Once you have those 5 to 20 examples sitting in front of you, you just work backwards. Look at the data and ask yourself, okay, what exactly makes this output so good? And what specifically makes this other one so bad? The quantified answers to those specific questions, those become your metrics. The data dictates the evaluation, not the other way around. Section 5, the 4 graders. We know the metrics, but who is actually marking the essay? Each grader plays a very specific role in a mature pipeline. First up, human evals. Having a domain expert sit down and grade outputs against your rubric is the absolute gold standard. But let's be real, it's slow, expensive, and completely unscalable. Second, we have user evals. This is the live signal from production, thumbs up, thumbs down, or maybe observing if a user had to immediately rewrite the agent's output. It's real ground truth, but it's noisy and only happens after you've already shipped. Third are code-based evals. Instant, cheap, deterministic checks. Did it output valid JSON? Did it call the right tool? Perfect for running on every single code change. Finally, the real game changer, LLM as a judge. Using a massive, highly capable model to grade your agent's outputs is what finally allows us to scale that subjective essay-style grading. But hold on, major warning here. An LLM judge has inherent biases. For example, they notoriously prefer longer answers, and they often favor whichever response they happen to read first in a prompt. So you absolutely must calibrate your LLM judge against human truth before trusting it blindly. Run your human graders on a small sample to ensure the LLM judge is actually scoring things accurately. But once it proves itself, it becomes the absolute workhorse of your pipeline. And finally, Section 6, the continuous loop. Let's talk AI CI/CD workflows. Let's tie all of this together into the ultimate workflow, the one that separates the fragile little demos from true enterprise-ready products. AI evals are not a one-time report card that you run right before launch and never look at again. You wouldn't test your regular software just once before launch, right? And you absolutely cannot test your AI agent just once. Just like traditional software relies on CI/CD pipelines to test code changes continuously, AI requires CI/CD combined with continuous evaluation and monitoring. Here is the actual continuous loop the top teams are running. First, define what good looks like and build that golden data set. Second, run a baseline score. You have to run your current system across the data to get a starting number. Because remember, vibes aren't data. Third, analyze the failures and group them. Are they all retrieval misses? Are they formatting screw-ups? Grouping them tells you exactly what to fix in your prompts or tools. And finally, you continuously loop through these steps and, crucially, rerun against your baseline to ensure you didn't accidentally break something that used to work. You know, that incredibly frustrating game of whack-a-mole. Well, running this continuous loop is the only way to avoid playing it with your agent's functionality. Without a robust eval pipeline, you might tweak a prompt to fix a super specific edge case for one customer, only to silently destroy the core functionality for everyone else. By running your automated evals on every single change, you catch those regressions instantly. And remember, the environment you are building in is never static. Model providers will literally update things overnight on you without saying a word. Your agent's behavior can completely change, even if you didn't touch a single line of code. That is exactly why your real-world user failures must constantly flow back into your golden dataset.
It has to be a living, breathing foundation that grows as your system faces reality. As we wrap up, I really want you to walk away from this explainer remembering this. True confidence only comes from relentless, structured measurement. The teams that are actually winning in this space, the ones deploying robust agentic systems, they aren't guessing. They treat evals like continuous automated testing, catching problems long before a user ever sees them.
So, as you look at your own projects and the AI agents you're building right now, I want you to ask yourself, are you building for the illusion of success? Are you crafting a magical but ultimately fragile demo? Or are you ready to engineer a robust, continuously evaluated AI product that actually survives the chaos of production? Ultimately, the choice comes down to your eval pipeline. Thanks for diving into this explainer with me, and I challenge you, go start building your golden dataset today.